So combining these two, what do I get? I get this, okay? But what's also true? Well, really from the previous slide, well, not the previous slide, but from an earlier slide, I guess it was the previous slide, if you divide like bases, you subtract the exponents, right? So here we have a to the 1 over a to the 1. That's a to the 1 minus 1, which is a to the 0. In other words, we have 1 is equal to this, but it's also equal to a to the 0. So a to the 0 is 1. I don't know if you saw that proof before. Maybe you did. I don't know, but I figured it'd be fun to do it now. Okay. But again, we are using the fact that a is not 0, mostly because of this. You know, this doesn't make sense if you do 0 over 0. That's what I'm saying over here. Okay. Yeah, I thought it'd be fun to do, so that's why I did it. All right. So, are there any questions at all?
No.
Okay. Am I going too fast for anyone?
Yes.
I am? Okay. So I can slow down a bit. So I'll go a little slower, okay? Okay. So next. So now we have some more exponents, right? Okay. So basically we have just a few more rules. And this is one of the rules that I'm just going to present quickly. Well, it's not, well, actually, this is another example building up to a rule. Okay. We have a cubed, right? And if we're going to square that, see? Okay, we're going to square this. Well, that's the same as a cubed times itself. A cubed times itself, okay? But what is that also equal to? This is also equal to a to the 3 plus 3. And that's the same as a cubed squared. So what do we have? We have a cubed squared is a to the 3 times 2. So that's what we have here. So in other words, you're raising a power to a power. That's the same as multiplying the exponents. And that's the rule I'm trying to illustrate. You raise a power to a power, you end up multiplying. Okay? That's what we're doing here. Okay, is everyone with me?
Yes.
Yep.
Yeah.
Okay. Okay. Good. Again, I don't want to go too fast, so if I do, don't be afraid to. I can't see you guys, so don't be afraid to yell. Okay. So, you know, I won't get upset. These are just some examples I threw in there. Just I thought they'd be helping us to illustrate what's going on. Okay. That's what I'm doing. So again, 8 we know is 2 cubed, right? So 8 is 2 cubed. Using the rule here, 2 cubed to the 4th, right? That's 2 raised to the 3 times 4, but that's the same as 12. So we get this. Good. 4 to the 10th, right? 10 we know is 2 times 5. So in a sense, I'm going from here to here. Actually, no, sorry. I'm going from here to here. This is 4 squared raised to the 5th. Okay, which is the same as this. I'm just illustrating the rule here. That's all I'm trying to do. But you end up getting this. That's all. Okay, so I'm going to move on. And even more, whiteboard 1. Okay, that's a mistake. That should not be in there. Okay. Okay, so hold on. This should not be here, so sorry about that. But these are just some other rules I put in here. basically, if you have a product, right, raised to a power, you do the same as this, a to the n times b to the n. That's really what you do. That's actually, you know what, here, let me get rid of the other ones. I'll get back to those, don't worry, but this is actually based on the fact that multiplication is commutative. In other words, you can multiply any two numbers in any order you want. So when you multiply and you raise to a power, that's the same as this. And likewise for a quotient, you have this as well. You know, when you're dividing and you're raising that to a power, you're doing that as well. Again, I am going a little, again, I'm not doing as many examples because really this is supposed to be review. But if you do need more help, you're more than welcome to contact me through office hours or even, you know, email. And I just threw this one in here. Basically, when you raise something to the -1 power, you're actually just going to flip it. More precisely, that means take the reciprocal. Okay? So when you have a fraction raised to a -1, you invert it. Okay? And I just threw in some examples here, as you can see. You know, we have 3/2 raised to the 4th, right? But again, using the second rule here, that's the same as 3 to the 4 over 2 to the 4, right? That's what I'm using here, right? The numerator and denominator, you're raising to the power. And of course, this is just 81/16. Here, I'm illustrating raising it to the -1. And again, that just means you invert it. That's all. You know, you flip it. Okay, that's good. Any questions at all?
Nope.
Okay. Was that too fast for anyone, or? Okay. Get that. So this is just another warning. Basically, I've seen people make this mistake I'm going to bring up. But how do I say this? So basically, if you have addition and you raise that to a power, okay? Unfortunately, addition's not as nice as multiplication in that, the mouse going, this is not necessarily going to be the same as this. If A and B are non-zero. So these are not going to be the same necessarily. And I can demonstrate that through an example as so. We have 1 plus 3 squared, right? Okay, so that's just 4 squared, which is 16. You know, nothing too fancy there. But if you do 1 squared plus 3 squared, right? This is 1 plus 9, which is 10. So basically what I'm demonstrating here is this does not equal this. I'm showing that with n equal to 2. Oh, sorry, step ahead. Okay, so basically I'm just showing that with addition you have to be careful. Okay, so I could do another backup example, but let me just see. So I did throw in some backup examples, you know, I figured it wouldn't hurt to do that. But this is just one example with one of the previous slides. You know, if you have 10/9 cubed, right? That's the same as 10 cubed over 9 cubed, which turns out to equal this. You know, 10 cubed is 1,000, 9 cubed is 729. Okay? And then if you raise it to the -3, okay, it turns out you end up getting this. It's just something I thought would be good to do. Okay. All right. Okay, let me stop there. Okay. Now, there was other stuff here. I threw in some other, I guess this shows more the calculation here that I threw in, so that's on the slide. Okay. All right, let me just stop sharing this. Okay, but again, it's all on the slide that I presented. So, yeah. Let me just get my video up. I'm going to stop recording as well.